Good afternoon. Sorry for not having this video posted up sooner. I'm posting it up and planning on you guys working on this tomorrow in class. If you get to it before then that's fine. But it will be through Edpuzzle yet again. Regrouping fractions is a lot like you've already done. All right, you're going to have to find a common denominator. You are going to need to add or subtract the fractions. So you'll be doing that, and you will also be borrowing. So that is what regrouping fractions is referring to. You will be borrowing a whole number from another whole number. So these are going to be subtraction only. Okay. So you're going to be looking at how you can kind of look at regrouping. Okay, what it actually means. All right. So I'm going to kind of walk you through two problems and see then if it can help you any better than what we have already done. Okay. So subtracting fractions, all right, we're going to estimate the difference of this problem, 2 1/6 minus 1 3/4. All right, we need to first estimate it to see whether we are going to, about where our answer should be. Okay, so in order to estimate this difference, you need to round up the second whole number, so the 1, all right? So to estimate, you're going to take the 1, you're going to round it up to 2, and then you're going to subtract 2 from it, all right? So you're going to subtract 2 minus 2, all right? So our actual answer, that if we were to subtract these two mixed numbers, our answer is going to be somewhere close to 0, meaning it's going to be less than 1. If you get a mixed number greater than 1, then you aren't doing the problem correctly, okay, and you need to re-look at it. So all this estimation is doing is giving us kind of about where our answer is going to be. That's what an estimation is, okay? So now if you were to actually estimate, or if you were to actually subtract these fractions, 2 1/6 minus 1 3/4, you would need to find the LCM of the denominators, 4 and 6. Okay, so find the LCM of that, it's 24, okay? Or actually it's 12, okay? But I'm going to use 24, okay? 12 is the actual answer. If you want to use 12, that's fine, but for this problem, I am actually going to use 12, okay? So in order to find out what 2 1/6 would transform into, I got to figure out what to multiply 6 by in order to be able to transform 1/6 into something with the denominator of 24. So 6 times 4 is going to give me 24, so I need to multiply the numerator and the denominator by 4. So 2 1/6 is going to turn into 2 and 4 over 24. Then I need to do the same thing to 1 3/4. What do I need to multiply 4 by in order to make it 24? Well, I'm going to multiply the bottom and the top by 6. So therefore, 1 3/4 is going to turn into 1 18 over 24. Now that I have a common denominator, I can actually start subtracting, but the problem is that I can't take 18 over 24 out of 4 over 24. So what I need to do is borrow 1. So I'm going to reduce the 2 to 1, and then I'm going to add 24 and 4 together to get 28 over 24. All right. So remember that when we borrowed the 1, it becomes 24 over 24. So you're going to add the numerators together and leave the denominator. 24 plus 4 is going to give us 28 over 24. Now that we have something that we can start finding the difference of, 1 minus 1 is 0, so our whole numbers are gone. And 28 minus 18, when I subtract both the numerators, you're going to get 10 over 24, which is going to reduce to 5 over 12, which is less than 1/2. 6 over 12 is 1/2, so that's close to 0. So it's close to that estimate that we got. Okay, so 5/12 is the answer. Looking at the second problem, we're going to do it exactly the same way that we did on the previous slide. Let's first estimate where our answer should be. All right, so you're going to leave the 4 as it is. You're going to increase the 2 to a 3. All right, you're going to increase the 2 to a 3, And what's going to happen is you are going to end up, sorry, I'm trying to fix something real quick. You're going to estimate, you're going to round the 2 up to a 3, you're going to end up getting that 4 minus 3 is 1. So our estimation should be somewhere around 1, okay? And so then now that we've done that, we're ready to go ahead and start subtracting, okay? So when we've done this, we are ready to start finding a common denominator. So actually the LCM of 6 and 9 is 18, okay? That is the least common multiple. This time I've chose the least common multiple rather than just multiplying the denominators together, okay, which is always the other option. So we've got 4 and 2 ninths. We need to transform that 2 ninths into a denominator of 18. So we're going to multiply the top and the bottom by 2. So we're going to transform 4 and 2 ninths to 4 and 4 eighteenths. Then we're going to transform the 2 and 5 sixths to something with the denominator 18. So 5 sixths turns into 15 over 18 because we multiplied the numerator and the denominator by 3. So now that we have common denominators, we can start subtracting, except that we need to actually reduce, borrow. We need to actually borrow from the 4. So I'm going to borrow 1 or 18 over 18 from it, and I'm going to add it to the 4. So now it's 3 and 22 over 18. Now that we're able to do that, we're going to subtract our whole numbers. 3 minus 2 is 1. 22 minus 15 is 7 over 18. So 1 and 7 over 18 is going to be our answer, which is close to 1. It's close to our estimation. Okay? I know I was doing some fixes in there, but re-look over what this is. Maybe pause the video and re-look at what I've done here if you got lost in my corrections. Okay? Take your time on this. It's no different than what you've already been doing. The only thing that we've actually added in is the estimation, so that way you can actually see what the answer should be close to. So that way, if you have gotten an answer way past it, maybe you added instead of subtracted, okay? Or maybe you forgot, just like I had, to change that 4 to a 3, okay? So be looking at your answers when you're doing the problems on MathSpace or on the worksheet to make sure that if you estimated them, that you'd have an answer close to what you got. All right, good luck.